In this example, we want to find the critical points of the function y equals x plus 1 over x. And we can rewrite this function as x plus x to the power -1. Let's go ahead and take the derivative of our function. So y prime is equal to the derivative of x is 1, and the derivative of x to the power -1 is going to be negative x to the power -2. And we can rewrite this as 1 minus 1 over x squared. And sometimes it's going to be helpful to rewrite our functions with a common denominator so that we can simplify it a little bit. If we want to rewrite this so that it has a common denominator of x squared, this would give us x squared over x squared. That's us rewriting the 1. And we'll keep the second fraction the same, 1 over x squared. And now we can simplify this to be x squared minus 1 on top, and we'll keep our denominator of x squared. And you'll notice that numerator is a difference of perfect squares. We can actually go ahead and factor that if we need to, x minus 1 and x plus 1 on top. We'll keep the x squared in our denominator. Now, when we're taking a look at finding critical points, we're considering two components here. The first one is where y prime equals 0. And then the second one is where the derivative does not exist. All right, so let's go ahead and take a look at where y prime is equal to 0. We're going to take our derivative, set that whole function, x minus 1, x plus 1 in the numerator, over x squared equal to 0. And the only time a fraction is going to be equal to 0 is when the numerator equals 0. So we can set each factor equal to 0. We've got x minus 1 equals 0, and x plus 1 equals 0. And if we solve each of these equations, we're going to get two values here. X equals positive 1 and x equals -1. And we can also take a look at where the derivative does not exist. Keep in mind the only time our derivative is not going to exist is when we have 0 in that denominator. So that's implying that x squared would be equal to 0, or x equals 0. All right, now keep in mind when it comes to finding critical points, you only want to use the values that were in the domain of the original function. So if we go all the way back to the original, we've got y equals x plus 1 over x. The domain for this function was from -infinity to 0, not counting the 0. And then we also had the interval from 0 to infinity, right? We can't put a 0 in there for x because that would give us 0 in the denominator of that fraction 1 over x. So when we're looking at our critical values here, we're not going to include the x equals 0 since that was not included in the domain of our original function. So our critical points will be x equals 1 and x equals -1.